Hello everyone, I just wanted to do a quick video on 4.oa.4, which talks about factors and multiples and prime and composite numbers. Another keyword that will usually be mentioned is factor pair, which is basically in the name. It's a pair of numbers. I call it like a married couple that work together to equal a multiple. So for example, 5 and 5 is really saying 5 times 5, and that would equal 25. So a factor pair of 25 would be 5 and 5. And sometimes you would have factor pairs of multiple factor pairs. For example, the number, they say a factor pair of 24. Well, the way I can get a factor pair and find my factors is using a T-chart. And so by T-chart, it looks like a T, and you just place that number up top, and you just start from the beginning to the end. And so the smallest number a number can start with is 1 in itself, which is 1, and in this case 24. But I can also use 2. 2 times 12 equals 24. 3 times 8 equals 24. 4 times 6 equals 24. And I can't use 5. I've already used 6. Can't use 7. I already got 8. Can't use 9. Can't use 10. So here I can see that I have a total of 1, 2, 3, 4 factor pairs. And if you count each individual number, I got 1, 2, 3, 4, 5, 6, 7, 8. So this number has 8 factors. So that's just an example. So I'm going to dive right into the question that I want to talk about in this video. It should not take long, but this is an example how students will see 4.oa.4 on a test. So for example, they might see the number 20 is a multiple of factors. Now, if we go back to this, multiples, we can use our dump your brain for that, and they're going to be the same or higher. But now 20 is the multiple. So they want to know which factor, which means what numbers can multiply and make 20. So if we go back to here, I can look, and I already know my strategy because I saw the key in the question of which factors. And whatever this factor is, it's going to be a multiple. It's going to be able to multiply and equal 20. So I'm going to get my T-chart and write all of the factors in my factor pair. And I will say the first way is 1 times 20. Next is 2 times 10. I can't use 3. But I can use 4 times 5. And so these are my factor pairs, and so which means that my factors are, and I like to tell my students to go in a U, because you should have listed it from smallest to biggest anyway. So I got 1, 2, 4, and next coming around I got 5, 10, and 20. So I see all my factors that I need. Now, if I'm taking a test, I'm going to look for my dumb answers. The answers that I know are wrong. So if I look here, A says 1, 2, and 5, and I see a keyword only. B says 1, 2, and 3, and 6. Now if I look, 3 and 6 are nowhere on that chart. So I already know B is wrong, because 3 times nothing will equal 20. 6 times nothing is going to equal 20. Now, if I look at C, I see 1. Again, I see 3, because I can use 1. I can use 4 and 5, but I can't use 3. Again, 3 times nothing will equal 20. So let's look at D. It's got 1, 2, 4, 5, and 10, and the keyword only. So I'm going to go ahead and cross out my dumb answers so I can't think of a better word of dumb answer, but those answers are the ones that I know I don't even have to waste my time with. Now I'm left with the tricky answer and the correct answer. Now the keyword only means that only 1 and 2 and 5 are the only numbers that can be used to multiply to make 20. Well, that's a lie, because even though I do have 1 and 2, I also have 4, 5, 10, and 20. Those numbers are left out. So since they're saying these are the only numbers in the whole world that can equal 20, I know that's wrong, and that's my tricky answer. Now, D is my only answer that I have left. And if I were to check, it's saying we can use 1, which is true. 2, true. 4, that's true. 5, also true. 10, true. And 20, that's true. So all these numbers, this is everything we can use, and this is the truth. These are the only numbers we can use to multiply and get 20. Again, that T-chart will help you in using your dump your brain to see the different ways you can multiply and make 20. And always start from the smallest number, which is 1, and times itself. And so there. The second one kind of question that throws students off is which factor pair fits all the rules. Now, often they'll figure a factor pair. For example, 1 and 20, that's a factor pair. 2 and 10, that's a factor pair. 5 times 5, 4 times 5, that's a factor pair. So we need a factor pair. Notice I'm looking for keywords. And it has to fit all these rules. And in this rule, they're going to say it must be a factor pair, meaning it must equal 36. And then both of the numbers need to be composite. So out of the factor pair they're going to give me, they're going to be composite. So what I'm going to do, and really I need to rewrite this. On a test, you're going to see the word and. They're not even going to tell you you're multiplying. You just have to know for yourself that you are actually multiplying. So I'm going to say 12 and 3, 4 and 9. I'm going to say 6 and 4. And we could also say 9 and 3. And really, on a state test, they're going to get 2 answers that, that are super wrong that you can easily eliminate. And then you're going to be left with a tricky one. So if I look here, I'm going to know I'm actually multiplying because they said the word factor pair. That's my keyword. So I'm not just saying adding these. I'm actually more specifically multiplying these numbers. So since I know I'm multiplying, I always tell my students, just write it out so you can clearly see what it's going to equal. And so I already know 12 times 3, that's 36. 4 times 9 is 36. Now, 6 times 4 is actually 24. And 9 times 3 is actually 27. So here, if it does not even equal 36, that's what I need. I already know I can cross this one out and that out. In fact, these are my dumb answer choices because I already know I don't need them. They don't equal 36. Now, I'm going to look at the rule. Because I see a rule that says both of the numbers that we're using must be composite. Now, a composite number is a number that has at least 2 or more factor pairs. So if I look here, 12 and 3. Now, 12 actually is composite because if I look, and I'm just right over this, if I were to put 12 on the T-chart, I have more than one way I can make it. I got 1 times 12, 2 times 6, and I even got 3 times 4. Those are 3 different factor pairs, which means that it's not only one way to make it. But let's look at the other number. They're using 3. So if I were to put 3 on a T-chart, I actually have only one way I could use. 1 times 3. If I have only one factor pair, that is a prime number because there's only one way to make it. There's only one way to multiply and get 3, which is 1 times itself. So 3 actually is prime. Now, for the rule, I can't use that because both of the numbers have to be composites. So A is wrong, and that's my tricky answer. Because it did equal 26, but it didn't follow the rule because that 3 is not composite. Now, let's see B. I see they're using 4 and 9. Now, 4, I know if I were to put on the T-chart, I would use 1 times 4, and I could also use 2 times 2. So since it is 2 or more ways, at least 2 ways, that is composite. Let's look at 9. I can use 1 times 9, of course. And I can also use 3 times 3. So the 9 is also a composite number, which means B is my only answer because it follows the rule. Likewise, let's look at the third question. Again, you have to pay attention to the rule, which factor pair, which means these numbers, again, like I said, they're never actually probably going to show you. They're going to always put an and. And like I said, 2 answers usually they're going to give you don't make any sense. So if I look 12 times 3, that's 36. 6 times 6 is 36. 7 times 6, though, that's 42. And 8 times 4 is 32. So I already know these don't even equal what they're asking me. They're asking that it needs to at least equal 36. This couldn't even do that. So I know these are my dumb answer choices. They're super wrong. I can eliminate them very, very easily. But now, instead of both prime, let's say they both need to be composite. Now that they both need to be, oh, no, we already did both composite. Let me see. I'm trying to give both examples of how they might be tested. So, I know. One number, I had it right the first time, must be prime. So, if I look and I see 12 and 3, well, I already know 6 is actually a composite number, because if I were to put it on a T-chart, and we actually have one, 1 and 6, because 1 times 6 does make 6, but also I can use 2 times 3. So since I have at least 2 ways to make 6 two-factor pairs, that means it is not prime. It is a composite number. So these numbers, they're composite. And that doesn't follow the rule, because at least one of them needs to be prime. Now, we do know 12 is a composite number because there's more than one way to make it, more than one factor pair. But 3, that's prime. So this actually would be my answer, because it follows the rule that they're asking me. Now, with that being said, I had a lot of students struggling with prime numbers and composite numbers, and I want to make it very clear of a prime and composite. One way that can really help is knowing your rules of divisibility and using your dump your brain. But, for example, prime numbers are numbers that only have one factor pair, which means they're going to have 2 factors, and that's it. And what I mean by that, a T-chart helps us. For example, let's just spit some words out, like 3, 7, 5, 13, 23, and I'll even write a number that won't fit this rule so you can see why it cannot be prime. I'll give you an odd number, because sometimes they'll try to say an even number and an odd. That doesn't matter. Most of the time, most even numbers usually are composite, but still you can't just swear that it's composite, depending on how it looks. So some of the odd, let's do 21. I'll add that up there. And I will prove how 21 cannot be used as a prime by putting all these numbers on a T-chart. And by the T-chart, we're going to write all the ways we can make it, starting with 1 in itself. You always start with 1, because anything times 1 will be that same number. Now, the next way, none of these actually, 1 times 3 is the only way I can make 3. 1 times 7 is the only way. I can't use 2 times anything. I can't do anything. Only one way, which is 1 in itself, which is why it's prime, because it is only one way to make these numbers. Now, 21 is actually composite. The reason being is because I have more than one way. I can use 1 times 21, but I can also use one more way, which is 3 times 7. Which means if there's another number you can use besides 1 in itself, it has to be composite, because the composite number has at least 2 ways, which means one other way besides 1 in itself. With that being said, there are some common numbers and I'll show you guys how composite numbers, and some people don't know 51. 51 is a composite number. In fact, that'd be a number that I would memorize, that is a 51, because that number I know is always on a test, and a lot of students just don't know how to use the rules of the divisibility to figure it out. So basically, these numbers can fit, and that means they can be multiplied to equal these numbers. They can also be divided into these numbers. So let's say 1 times 4. Like I said, always start with 1 in itself. That is a given. Now, the next way depends on you're using your dump your brain. I know after 1, we usually try to see if we can use 2. And 2 times 2 equals 4. Now, these are actually the only ways. Even though it's not that many, it's still composite because it has at least two factor pairs. That means at least 2 ways, 2 numbers, 2 different sets of numbers you can multiply to make it. Now, 6 is also composite because I do have 1 times 6, but I also have 2 times 3. So those are 2 ways, and that means I got 1, 2, 3 factors in this case because you can't count 2 twice. So these are my factors, individual numbers that I'm multiplying. Now, 12 is a bit more popular. I can use 1 times 12, I can use 2 times 6, but I can also use 3 times 4. Notice I'm keeping them in order from least to greatest. So I see I got a handful of factors here. A lot of numbers like 12. He's pretty popular. 15, not that many ways. I got 1 times 15, but I can't use 2 because 2 times nothing would give me 15. But I can use 3 times 5. And these are my only 2 ways I can use to make it. And 21 is also composite because even though I have 1 times 21, I can also use 3 times 7. And some numbers will have more factor pairs than others, but the bottom line is if it has more than 1 factor pair, more than 1 way you can multiply and get it, it is composite. Now, 51 is a tricky one. Most people don't know that, but if you look at the rules of divisibility, it doesn't have an even number or 0, so I can't divide it by 2. But I can use 3 because if you were to imaginarily add up 5 and 1, the rule of divisibility for 3, if the sum of the digits is divisible by 3. Sum means add. So if I were to add 5 plus 1, I would end up getting 6. And 6 can actually be divided by 3. So as you can see here, that's a factor. So that means I would divide it real quickly to see what factor can fit, what number can multiply by 3 to equal 51. So I would do long division, and I would say 3 times 1 because I can't use 3 times 2. And 3 times 1 is 3. I would subtract that, make that a 2, make that a 1. Well, I know 3 can fit into 21 perfectly because 3 times 7 is 21, which means that 3 times 17 can actually equal 51, and that makes it, since that means it has more than 1 way to make it, it is a composite number. And then I'll even write a problem and show you why it cannot. The reason why I'm doing this is so you can compare how this has 2 factor pairs, and these have more than 1. This has at least 2. So I'll say the number, I use 17. Now 17, there's only 1 way to make 17. That's 1 times 17. As you can see, there's only 1 way to make this, only 1 factor pair. The rest have at least 2. So that means this number cannot, because it has this right here, couldn't be prime because it had too many factor pairs. This one does not have enough. It only has 1. So that means this is a prime number. And the last thing is multiples. And I covered factors. Factors you're finding in the T-chart, and those are just the numbers. Like the factors are 4, 1, 2, and 4. The factors are 6 are 1, 2, 3, and 6. Those are just the numbers in the factor pair. Now, multiples are numbers that get bigger and bigger. Think about it. When you multiply, you're getting bigger. Factors is kind of like you're dividing. It's like you're unmultiplying. So factors are, of course, going to be smaller or even the same if you use 1. Multiples are going to be bigger. So if I were to say the multiples of 8 are the multiples of 5, that's very popular. Well, we already know the multiples are 5, 10, 15, 20, 25, and I can just keep going. Multiples, you can actually go on an infinite way because you'll never run out of multiples. I can even multiply 5 times 10 million or gazillion, and I will get, you see what I'm saying? Like, you will never run out of multiples. There's always many, many numbers you can multiply. Now, factors, there's only a certain number you can use to multiply to get that number. So the multiples of 5, they just keep going, which is 1 in itself, 5, because you can say 5 times 1 is 5, but then I can say 5 times 2, 5 times 3, 5 times 4, 5 times 5, and so forth. So multiples will always be bigger, the same, or bigger, and factors are be the same or smaller. Like if I said, give me the factors of 20. Well, I would have to use a T-chart, completely different strategy. And I'll use 1 times 20, 2 times 10, 4 times 5. And here I can see my factor pairs, and I know the factors. Those are the numbers in the factor pairs. And I got 1, 2, 4. Next will be 5, 10, and 20. So these are my factors, which, as you see, it can be the same if you multiply it by 1. And then the rest are just going to be smaller. 5 is smaller than 20. Like I said, it's kind of like division, and multiples are obviously in its name multiplication. So again, this is all I have for you. I hope it helps with any confusion about factors, multiples, prime, composite numbers, factor pairs. Have a blessed day.